Hello everyone, welcome back to the C programming tutorials. These tutorials are brought to you by Zeedup technologies. In this video, we are going to discuss about pointers on arrays in C. In the previous video, we introduced ourselves with the concept of pointers and we saw that how can we create a pointer to an integer variable, a pointer to a character variable. We also even saw that how can we create a pointer to an array. Now in this video, what we are going to do is we are going to see its practical application. That is, first of all, we are just going to create a pointer variable to a single dimensional array, and then we are going to create a pointer variable for a two-dimensional array. Okay, so first of all, we will talk about a single dimensional array. So let's just enter a comment that 1D array pointer. That's what we are going to do. That's the 1D array whose pointer we are going to create. So let's see that how can we create a pointer. First of all, you need to create an array for that purpose. So I'm going to create a simple array of 3 elements, and I'm going to store the elements like 10, 20 and 30 in it. Alright, then what I'm going to do is I'm going to create a pointer. Since I'm going to create a pointer for this array which is holding the elements of integer data type, that is why I have declared the pointer with integer data type. Now using the asterisk sign, I make sure that I am declaring a pointer and write the name of the pointer, that's P, and then simply I can write the array name, that is ARR. So this is another way of declaring a pointer to an array. There was other way which we saw in the previous video, but this is also a way. Okay, now to access these 3 elements and their addresses, we know that the pointer is going to hold the address. Okay, so how can we access the address? Actually, this pointer P will hold only the address of the 0th element of the array. Okay, so using this pointer, we can access the address of the 0th element. How can we do that? Simply write a printf statement, say address, like this, and then put a mod d, a mod x actually for a hexadecimal value, because address is a hexadecimal value, and simply you can press P or print the value of P. Now if we just compile it and run it, what do we get is a hexadecimal value which is nothing but the address of the 0th element. Okay, now what if we want to print the value of this element through pointers? Okay, we know that P is a pointer that is pointing to the address of the 0th element of array ARR. Now we want to print the value, that is 10, with the help of pointers. So how can we do that? Simply write a printf statement, value, this is just a decoration, mod d for a placeholder, and then for printing the value, what you need to do is write asterisk P. Now this asterisk P is asterisk over here is a dereferencing operator which dereferences it, which dereferences this pointer P, which means it gives the value of the variable whose address is stored in this pointer P. So let's just run it and see what happens. That's perfectly fine, that's perfectly correct. We have got value as 10 and this address, so that's absolutely correct. Now this was let's just add a mod or a \t for differentiation purposes. This was just for the 0th element. What if we want to access the values of, say, more than 0 element? We want to access the values and the addresses of all the elements in an array through pointers. Then how can we do that? So for that purpose, we need to just use a for loop again, or any other loop basically, but we need to use a loop because we need to iterate through multiple times, through the same code multiple times. I can simply write int I equals 0 and I less than equals to 2. That is my termination condition. Why I have used it? Because the index number is from 0 to 2. 0, 1, 2. These are the 3 iterations that I am expecting from this for loop. And then I can just write I plus plus. And now what I need to do is I need to make some changes over here. So within the parenthesis, in this P, I need to add this I and just close the parenthesis Okay, and similarly over here also we need to do the same thing. That is, we need to add p plus I. So what does this I do? First of all, the value of I will be 0, which means the address stored in this p will be displayed. Then the value stored in this p will be displayed with this statement. But since the value of I changes to 1, what happens then is the address of the first element will be displayed and then its value will be displayed. And similarly, when the value of I changes to 2, all the information related to the second element will be displayed. This is how you can access all the elements of an array using a pointer. So let's just run it. Okay, so we need to first compile it and run it, or we can just click on this compile option. Okay, so this is it. We have got 3 addresses and 3 values. The reason why we are able to get this kind of an output over here is a very simple one, because an array, as you can see, is a homogeneous data type or a homogeneous type of data it stores, and it stores it in a continuous fashion, which means that in the memory one block after the other is occupied by the array itself. That is why we are able to access all the elements of the array in this fashion by just adding 1, 2 and so on. So this is an advantage we get by the use of pointers, and because of the concept of arrays. If we can use any of the data structures like say structures, which will not be giving us this kind of advantage if they are not stored in kind of an array format. Okay, so this was about 1D array. Let us now talk about a 2D array. So this is a 2D array pointer, right? So let us just declare a 2D array, a very simple A, just the A for the array. And what we are going to store is 2 by 2. So 2 rows and 2 columns. And let us just initialize it as well. Okay. So it's going to be 2 elements, say 12 and 14. And in the second row also it's going to be 2 elements, say 13 and 15. Okay, any number of the elements could be there. Now once we have declared the array and we have initialized it, what we can do next is we can simply just use the for loop. So let us just write the for loop. Integer would be I equals 0, I is less than equals 1 because they are just the 2 elements, and I plus plus. Within the body of I, we want to first print the address. Okay, so how can we print the address? It's a very simple one. We can just write printf statement address and of mod d array. That is, we want to print the address of this array. Basically, this is the whole code for the usage of a 2-dimensional array, and what we have done over here is basically we have written this 2D array with 2 rows and 2 columns. We have stored 12, 14 and 13, 15 over here. Then using the first for loop, we have iterated it for the rows. So we are going to print the address of the rows, which is possible through just asterisk a plus I, and then we are also going to print the row number, that is the address of the 0th row and its address. Okay, after that what we are going to do is we are going to print the values. So this is a simple example on how you can print the values, and basically there is another way through which we can print the values. Let's just try that. That is very simple. What you got to do is put an asterisk, a parenthesis, again an asterisk, again a parenthesis. You can just write a plus I, close the parenthesis and add j to it, and then again close the parenthesis like this. Okay, so this is another way through which we can actually print the values. Let's just try and run it to see what happens. Okay, so this is working perfectly fine. We are getting the address of the 0th array, that is the 0th row. This is the address, and then we are getting the 2 values present in it. Similarly, we are getting the address of the first row and the value of its address, and then we are getting these two values that are present in it. Okay, so let's see how it works. We all know that this a plus I is going to give us the address. Okay, now over here what happens with this a plus I, we get the address of that particular row once again. Okay, now when this plus j is added, so we iterate it twice, which means the address of j will also be added, which means the like for the individual columns we would be able to see the stuff for the individual columns, right? Now when we use again this asterisk or this dereference operator, it means that we are actually referring to the value instead of the address. So this is twice the asterisk. The first asterisk makes it a pointer, while the second asterisk makes it a dereferencing operator, or it just converts the things into values. If we just get rid of it and write like x, and now we run it, then what happens is we get the address of the individual columns over here. This is the address of the 0th column and the 0th row. This is the address of the 0th row first column. So this is how we can actually access the addresses and the values of the different elements in a one-dimensional array. And that is all you need to know about the pointers to arrays in C. Thanks for watching.